With that, I'm really interested in hearing this talk. So, Authz, give it away.
So thank you all for joining today. Good. In this talk, I'll be presenting Spring Boot Netflix, or as we call it, SBN at Netflix. Spring Boot Netflix, our application framework, powers over 3,000 applications at Netflix. We're currently leveraging the latest 3.3 Spring Boot version. We use standard Spring Boot auto configuration and building blocks to kind of customize the Spring Boot experience for our Netflix application in a way that we add our own opinions, and it's specifically tailored for Netflix. But I'm not here to kind of talk to you about, oh, okay, we're using this and this. I want to kind of show you maybe what we are doing and maybe inspire you in your own project. This is like not an open source software that we're kind of providing, but kind of show motivation and perhaps things that inspire you. So most of you are probably familiar with the Netflix product, right? This is the experience that over 270 million subscribers worldwide are enjoying every day. And SBN is very much part of this use case. SBN, this is a very simplistic view of the streaming use case, where, as you can see, all the green boxes here, these are Spring Boot application, Spring Boot based microservices for mid-tier and backend services powered by Spring Boot. But streaming is just one use case that we have at Netflix. We have various other stuff. Some are, have different characteristics. Some are high RPS, like streaming, or subscriber, when you subscribe to the service, or anything to do with payments. But some of them also like low RPS, whether it's studio application, enterprise applications. Some are not even serving traffic. The entire flow of encoding a video and doing things offline as batch workloads. All these different use cases, these are all powered by Spring Boot-based applications and have different characteristics. Now, before I dig into, I kind of want to explain other services we have in our platform in the ecosystem, because Spring Boot Netflix SBN integrates with these. We have Eureka. I'm sure many of you are familiar with this. This is an open source service that is provided, that we use at Netflix. This does registry of cloud servers. So we use it for service discovery, load balancing, and failovers. Fast Property is a cool service where we provide our application owners the ability to change value of properties without changing their application. So this happens at external service, but the value or the changes propagate all the way to the instance. Think of like I think Launchdarkly does something similar, which is like feature flags if you want to like change timeouts and stuff like that. Other things that we integrate with is our Insight Log, distributed logging system. So all our logs are pushed from the instance to a remote server. Same goes for our tracing data as well as our metric data. We all push it to an external service. We also collect some metadata about the running application. That metadata actually serves us as a platform team, so we know which features are being used, how long does it take for an application to start, what type of version they're using, what type of Java version they're using. So all these platform services, these are not something specifically that an application needs to integrate with. As part of the Spring Boot Netflix solution, we integrate for the user. And this is kind of like a bird's eye view of the kind of how a typical microservice, Java microservice will look at Netflix. We have the Java processes channel, the VM. So Spring Boot Netflix, as I mentioned, is built on top of Spring Boot. And on top of that, this is the application-specific code. The business logic need to power a certain use case. And Spring Boot Netflix integrate with the various platform services, whether it's directly by connecting to remote services, or whether calling some sidecar processes running on that same instance, which themselves connect to the external services. And again, all those integration points, these are just using standard Spring Boot building blocks, whether it's auto configurations, whether it's environment post-processor to kind of change the values of properties that are reading, hooking into the application lifecycle by using application listeners or application context initializers. All right, before we dig into more into SPN, I want to talk a little about dependencies. Dependency management is critical to any large application. If you write a very small application, yes, you can probably not care too much about your dependencies, but as code becomes more and more complex, dependency management becomes a very large task. If you try to do it manually, you need to figure out, do you have the correct dependency on your class path? Are you using the correct versions? Are these versions compatible with other dependencies and their versions on the class path? And how do you resolve conflicts? Do you use excludes? Do you force a specific version? Use constraints and all sorts of different mechanisms. So at Netflix, specifically for applications using our SPN framework, we leverage what is called starters, very similar to Spring starters, but is specific to Netflix dependencies. So a starter is basically a composition of all the dependencies needed for a specific feature. We have an example of like the REST server. So if you need a REST server at Netflix, you add the Spring Boot Netflix starter REST server. This will in place add when necessary Spring dependencies like the Spring Boot starter web or the actuator starter, but we'll also add Netflix specific dependencies like all of our observability dependency, resiliency dependencies, security, and such. Other type of features, other type of starters would be like a gRPC client. If your application needs to communicate with a gRPC server, from your point of view, you just need to add a gRPC client and you have all the necessary dependencies you need to create a gRPC client and communicate. You might have noticed in the previous slide that I didn't specify a version for this dependency. The reason I didn't specify versions because at Netflix we use what is called recommendation. We basically have a BOM file. BOM file is a bill of material where it contains the different dependencies and the recommended versions for that dependency. We apply a plugin that is it's called the dependency recommender. Also open source by Netflix, but it's very similar to the Java platform Gradle plugin, which again looks at the BOM and picks up the version that you recommend for this application. So an application does not have to specify the dependencies for many of the dependencies. It does not have to specify the version for many of the dependencies that it has, and the plugin will just scan through the build.gradle file, see that it's missing a dependency, and will apply that version. And that way, it gives us fine control into controlling the different versions used in those applications. I want to talk about how to create this BOM. Very simplistically, it's a composition of the open source Spring Boot dependencies, which itself is a BOM. So we take all the dependencies from there. We take all the dependencies that our framework itself depends on, and any manual recommendations that we add as well. We compose all that together. We do version resolution, basically taking the higher version in many of the cases. And we rely on the fact that if all our integration tests are passing and the build runs fine, we have some level of confidence that these dependencies are compatible with each other. It's not 100%. We run into issues every once in a while, but it's a pretty good state where everything kind of passes. One more thing about dependencies, we have a SBN Gradle plugin. That plugin gives us another hook into the build phase, so we can be more opinionated of an application dependencies. It's not just dependencies. Yes, we have more things that we can add in this plugin with regards to dependencies, but we also do things like Docker file generation. So an application at Netflix can be deployed directly on an EC2 instance, but it can also be deployed using Docker. The application owner itself does not need to care about this. It doesn't have to specify a Docker file. we generate a Docker file on the fly, so we can then decide whether it deploys to an EC2 instance or the Docker instance. And we also do other things like the Jakarta transformation that I explained earlier in the keynote. All right, let's go a bit deeper into Spring Boot Netflix, and I'll start with properties. Properties are it's a useful mechanism. If you want to change the code behavior, you can do that outside the compiled code. But property, the values, they differ based on the environment you run. If you run on production, on your laptop, or you run in a staging on a test environment, you might want to specify different values. The classic examples are like database URLs or the credentials, or you might want to disable a certain functionality in your application when you run in CI or in laptop. What we do is we rely on Spring profiles to do the segregation between the application property, between the property values based on the environment. But how do we hook that in? So to do that, we rely on an application environment prepared event that is fired very, very early on when the Spring Boot application starts. It fires so early that only the environment object is created, but none of the properties were loaded at this point. What we do, our code at this point, is that we detect the environment we're running on using environment variables or just detecting the type of the machine. For example, if you're running on a Mac, we know that's probably a laptop. If we're running with a certain environment variable set to test or staging or production, we do that as well. We also can detect which region we're running on based on AWS-specific environment variables. So once we activate those profiles, Spring takes care of loading the correct properties files and meshing all these together. One way of specifying profile-specific properties is using, as you can see on the left side, is a file per active profile, but you can also specify a single application YAML file and have a multi-document, which then for every profile that's active will load the correct section. So I talked earlier about the external system we have for changing property values. We call it fast properties. The way we kind of integrate to make this work is when the application starts, we call that external service and fetch all the properties that are related to the specific instance. Then we add a property source. Property source is properties in a Spring Boot application is basically a list of multiple property sources ordered, where when you try to fetch a value of a specific property, you go from the top to the bottom. When you find the first one, that's basically the value that you will get. So by specifying remote as a very high up in the list of property sources, we ensure that if someone wants to set a remote property, this will take effect for his application over any libraries or even any application properties values that exist. And so we fetch it early when the application starts, but we also fetch every 30 seconds. We fetch the delta of the properties changed. And when that happens, we call an event to trigger this method. So we introduce an on-property change annotation that you can specify the name of the property. And when there's a change that happens, we will call this method with the correct value. In this specific case, think about it like a feature flag, whether it's enable or disable. This kind of works in the implementation point of view, very similar to how Spring implements event listener. And we do the same and call this method. Cool. So, all right. One more thing about properties. Very common use case that we have at Netflix is that we need to store secrets. We need to store secrets in our properties files. For example, when you want to connect to a database, you need to specify the database credentials. You need to set client secrets, password, access tokens. You don't want this visible in your properties file. So these properties files are committed into a repo, a Git repo. Sometimes you might push it into a place where others might have access to. This has been a cause, I guess, of many issues in the past for many companies. What we do is we check in the encoded secret into the properties file. And by using a tool that we have, it's called Metatron. The name, it doesn't really matter, but what Metatron does is just credential management, certificate-based credential management for the machine. Basically, each machine has the locally minted certificate, and when the secret itself needs to be encoded, what we do is we detect that there's a prefix of Metatron, then we take the encoded string along with the identity of the running instance. We send it to the external service, and then that external service, based on whether we have access to the secret or not, will return either the decrypted secret or an error, in which case will probably just fail to start the application. The way that it kind of works is we have a specific conversion service that then detects this prefix and knows, okay, this is how I handle this type of property. Any other properties, it would just not handle it. All right. So at Netflix, we highly use Spring Security. Our stance with regards to security for Spring Boot application is it's secure by default. What does that mean? It means that all the endpoints of an application has to be authenticated. The only exception is probably the health actuator endpoint, and that's mostly for legacy reason with regards to load balancers and stuff like that. But all other endpoints are secure by default. As I mentioned, we are highly integrated with Spring Security, and we have various ways on how you authenticate with our application. If you're a client through a browser, it happens through OAuth 2 integration. If it's a call from between a service, then it uses mutual TLS. As I mentioned, every service has its own minted certificate, and when you make a call, both the client and the server both know about each other and can authenticate the request. Even when we do command line calls, like using curl, so we have a revised curl command which uses mutual TLS to make the call. So even when we do testing or not even running on production, all of the communication happens securely and encrypted. All right. SBN organizes application resource into groups we call security realms. A security realm, our concept is basically all the common security constraints like authentication method, authorization rule, grouped into a handful of security realms. We have the app realm, which is mostly all of the endpoints of an application. Admin are the administration-specific endpoints. It's mostly the actuator endpoints. So endpoints that only admins of this specific application are allowed to change. And we have an anonymous realm, but which by default is empty. But you can add specific endpoints if you want them to be unauthenticated or be able to call them unauthenticated. An example might be, let's say you want to serve some JavaScript or a CSS file. You don't need authentication for that, then you can add it to the anonymous realm. Custom realm would be some special use case that you might have. So each realm is a group of endpoints that it governs. The way that we segregate it is by using we use the Web Security Configure adapter, which gives you access to the HTTP Security Bean. Using the HTTP Security Bean, we apply request matcher that segregates between the different realms. And for each segregation, then we can configure different aspects. For example, I mentioned the admin endpoint requires authorization as well. So we configure that specifically for the request matcher. When we use Spring Security, Spring method level security for access control. We use the out-of-the-box @security annotation that you then provide a role that will govern whether a user is authorized to make a call to these methods. In this specific case, this role, we call it a logical role. It doesn't map to the backend service that we have for that does the actual authorization. It just maps to a role mapping that we have in our configuration file. So by having a logical role, we allow the user to basically change the value of the policies based on perhaps the environment he runs. If he runs in production or when he runs on a test environment, he might define different policies. So this is the reason why we added the logical roles. So we automatically integrate with security, send the identity of the user to make the authorization request against the authorization server. Security is mostly used, but we also support the pre-authorized annotation that comes with Twin Security, and this gives much more flexibility into the various authorization logic that is needed. We extend the idea of identities at Netflix because by having multiple identities on the request chain. So a request can start from a user making a request to a service, in this example, application A. But then to serve this request, application A might call an application B. And it could be a long chain of applications for this call. We propagate the multiple identities with the chain for each of these applications. So if for example, application B is able to see that the initial identity of the caller is actually Alice, but you can also see what is the direct identity, which in this case would be app A, because that's the one that made the call to application B. Having access to these identities, the initial identity specifically is automatically configured when calling authorization. So the previous slide I showed the @security and the role. We use this identity to send the request for authorization to the backend service, so to whether grant or reject requests for the user. But you can also access the multiple identities programmatically. We use what we call SSO caller or SSO caller resolver to get access to the specific identities of the specific request. In this example, think about this method on the request path as some method that is executed to serve some traffic. So a request comes in, we know the initial identity and we know the direct identity, and we can get this information. Getting access to the caller identity, you can look whether the caller is a user directly or if it's an application, and based on that you can retrieve additional information like the email if it's a user, or the full name, or if it's an app you can get the app name or even the account ID of that specific application. All right. IPC at Netflix. So we use various technologies. We use REST, Spring MVC mostly for server-side REST calls. We use web client and REST template to make REST calls to our REST servers. We also have legacy clients that predates our adoption of Spring at Netflix. We use GraphQL, specifically the DGS framework, and Paul, my friend, will have a talk tomorrow about how you use Spring GraphQL in a Spring Boot application. And we also use gRPC, both client and server. This is mostly when you do server-to-server communication and we need high performance. So I can spend a full lecture just on IPC, but specifically I'm going to focus on the IPC client side and specifically gRPC. So this is an overall anatomy of a Netflix IPC client. We have the client data model and the client API, which correlates to classes and the method that are being called. Then it goes through some serialization, deserialization. Then we add our own specific logic in the interceptant parts. So we load specific properties and add core integrations. Then we have name resolver, like integrating with Eureka or load balancer. All of these compile into just any IPC client at Netflix, whether it's REST, gRPC, GraphQL. gRPC specifically, we use Proto, and using Proto, we generate using small windows and schema, we generate the classes and methods that are being used. And we have gRPC interceptors for more customizations. All right. When it comes to making a gRPC call against our server, we wanted to make it super easy for our consumers. So we wanted, from an ergonomic point of view, to provide them out-of-the-box facilities to first generate the clients. Also, for this, we use a schema, which is protobuf. We do code generation for classes and methods. Everything is configured by property. So you can change specific interception and specific configuration of an application by changing the value of a property. So a gRPC server will provide the schema for its service and would provide the properties and will provide it through a thin client library that is fully generated for the user. The user will then use that client library and will inject a stub that we can then use to make a call to a gRPC server. We have in our interceptors, the core features would be like observability, like access logging, metrics, tracing, resiliency features like retries, concurrency limiters, fallbacks, and many other features that all bundle into a pre-configured gRPC client. So this is an example from a user point of view. The top level part is what the server, the gRPC server property defaults would be. This is controlled by the gRPC server owner and is shipped in the client library. From a user point of view, all he has to do is, right here at the bottom, is use this gRPC Spring client annotation, provide a name in that annotation. That name correlates to, as you can see in the properties, the gRPC client and the name of the properties. And all this will be loaded and configured automatically and injected. So the magic here is that, as you see, it doesn't specify, it doesn't instantiate the object. It doesn't instantiate the stub. We do this for him magically as part of the application. Kind of explaining a bit more what we see. The blocking stub, test app service blocking stub, this is the part of the generated code from the schema. And the stub is a dynamic bean that is created automatically. And I'm going to go into details exactly on how we do that. So how is the gRPC Spring client implemented? Again, we use building blocks from Spring. We use something called the bin definition registry post-processor, which is a mouthful. What that does, it allows you to programmatically register bin definition. Bin definition registry post-processor is invoked after all the static beans of an application are defined, not created yet, but defined. So if you have classes annotated with add component, or if you have in your configuration class methods that annotate with add bin, these all translate to bin definitions and are available for hooks like the bin definitions registers post-processor. We use reflection utils and annotation utils to further inspect the classes to find the annotation, the gRPC Spring client annotation. We use bin definition builder to create bin definitions. And the factory bin is used, it's a special type of bin. It's used to create other bins. You might use it for several reasons, like if you want to create proxies, or if you have very complex logic for instantiating the instance. In our case, we wanted to create a segregation between when we define the instance dynamically and when we create it. So this is this is a watered down version of the logic that we have to create those dynamic bins automatically. So as you can see, this is bin definition registry post-processor, and the method post-processor bin definition registry gives you a hook in the life cycle of the Spring Boot application. At this point, it happens after all the static beans definition has been created. So we can scan and get all this data, but before any other bean definition registry post process have been invoked, or before the beans themselves were created. So what we do at this point is we get all the classes of the beans, just get the classes themselves, then we iterate through all the classes. We find, for each of the class, we use reflection utils and annotation utils to figure out whether they have the gRPC Spring Client annotation. We look at fields, we look at constructor parameters, and we look at method parameters. When we detect that this usage has happened, we grab the value of the gRPC, the value of the annotation, the client name, along with the class that it was annotated with, and then we pass it to the register bean method. In the register bean method, we load the specific client properties. We create a unique bean name, which is mostly a concatenation of the client name and the specific stub class. And the reason we do that is that we don't want to create multiple bean definition for the same client and same stub, because you could use that same annotation in multiple places, and we wanted only one singleton bean to be created. For creating the bean definition themselves, we use the bean definition builder. Here we specify that it's using the specific factory bean. We're passing the class that is to be created along with the client name. And that's how we create the bean definition. An important part is that we add a specific qualifier for the gRPC Spring Client, and that enables when you make the injection using that annotation and the client, that it will know that this is the bean that needs to be injected versus just any bean that implements this class. And then the actual method is register bean definition with the bean definition that we added. So this is more or less the magic behind the gRPC stub factory. The magic behind the gRPC Spring Client annotation. All right, so let's wrap up a little bit about what we did, what we talked about. At SBN dependencies, we use starters. That's a composition of the various dependencies that we provide to an application. We use version recommendation using a bump to specify the version for a dependency. And we have a custom Gradle plugin that gives us further hooks and to add our own opinions in the build phase of an application. For properties, we use profile activation to segregate or be able to load different property values based on the environment. We use remote properties, and we have encrypted properties support within the properties file. For security, we talked about the realms, which is the security groups and the specific things that we set for a group of endpoints, how we do access control, and how the concept of caller identities. And in IPC, we talked about the different IPC frameworks we use, but we dug into specifically how we do gRPC clients and how we create the dynamic beans for our applications. At this point, I'm open for any questions you might have. Thank you. Yeah, go ahead. Oh, microphone. Hold on. That.
Is it on? Regarding your properties approach there.
Okay.
Oh, can you hear me now?
Yeah.
Okay, sorry.
provided back then by Spring Cloud Configuration. Cool.
Any other questions? Come on, we got Netflix in the house. Oh, there we go.
You said that you support multiple identities in the REST core chain. Are you support only two corner or you pipeline everyone? And how will you pass around?
All right, that's a good question. I actually skipped through that in the presentation, so I'll elaborate a bit on that. So we have a dedicated token, what we call an E2E token, where we place the identities, and it is being propagated as we make calls between the services. The propagation happens in the specific client. So whether you use a REST client, a gRPC client, using GraphQL, we propagate it using a header to kind of propagate the different identities. At this moment, we only support the initial identity and direct identity. So the direct will keep on changing as you move through the chain, but nothing really prevents us to keep the entire call chain with the multiple identities. I think at this point, we just don't see a use case for it, where for the two identities we do. Good question. Thank you.
Cool. Any other questions? All right, we got one here.
Hey, we already have these components with Spring Boot by Spring Community, right? What is the necessity for me to learn and all these components with Spring Boot Netflix at this current environment?
All right. So if I understood the question correctly, it's like, how do you learn about the different building blocks that Spring itself provides? Spring Boot have a wide range of documentations for all the various things that they have. The way that we kind of learn about things is reading through the documentation that they have, but also digging through the code and seeing, okay, they're using other configuration and this specific class, but we want a slightly different behavior, but it's very customized because everything is conditional on missing or stuff like that. So we can add our own behavior to kind of replace specific beans. Specifically with regards to context initialization and environment post-processing and all that, these are well documented, so you can read about the various hooks that Spring itself provides for you.
Cool. Any other questions? Got one here.
Do you also use the Spring Boot for the streaming part of Netflix?
All right, yes, so definitely. As I showed in the beginning of the slide, most of our mid-tier and backend services serving the streaming path are Spring Boot applications. Other than probably the gateway that is very unique, all of the thing that happens afterwards is Spring Boot applications. We had previously, about 5 or 6 years ago, we started embarking onto the Spring journey. Before that, we had the proprietary Juice-based framework, but we've since then moved everything to Spring Boot, and now most of them are on Spring Boot 3 as well.
Yes. Love to hear that. All right, got another question here.
You mentioned earlier in the presentation about dependency management and how you guys are using Spring Boot Starter Netflix, and that handled and abstracted away a lot of the complexity with dependency management. But you also mentioned a couple edge cases where not all of them complied. Can you speak more to those edge cases and how you went about resolving them?
All right, so one kind of, I guess, a trade-off that you have is when you compose dependencies together, you want to make sure that you add the required one, but not the optional ones. You could have a starter that if you start adding all the dependencies you may need, this will basically add those dependencies to your application as well as transitives. So what we try to do, and we keep on iterating and keep on always kind of trying to improve it, is to make sure that starters only have the very minimal dependencies needed for the feature to work. If there's additional feature or additional things that needed, you could still add the relevant code in the starter, but use like things like conditional on a class or other types to kind of make sure that it is not being added automatically, at least unless it's on the class path. And for that, you just have more starters that will add the necessary optional dependency. A very simple example, not simple, but an example that we have is we have EVCache. EVCache is a caching solution that we have based on Memcache. By default, an application can say, hey, yeah, I want EVCache, then I add this EVCache starter. But some applications might also need replication across multiple regions. This is an optional feature. This is not a must. And replication has more dependencies in it. Like, for example, it brings in Kafka because that's how it does the replication. We don't want all of our users, all of the EVCache started users to also bring in Kafka. So it's only specifically if you need replication. So that's a good example.
All right. Any more questions? Going once? Going twice? All right. Thanks, Aussie.
All right,
Appreciate it.
thank you.